I mean, now we are almost towards the end, of this mass balance business. So, I mean, now doesn't make much sense. We can at most try some questions, isn't it? Now we
Yes,
can't go
sir.
back, right? So whatever needs to be done, I think you already have that. And this week, last week, we just try some questions. That's about it, right? If you want, if you are bored of this simple question, I can give you something much more complicated. There's no problem. Actually, who was that? Ashi? Was that Ashi's voice or?
Yes, sir. Yes,
Yeah,
sir.
I mean, the truth is, this whole business, when you say recording, it gives the feeling कोई हम बहुत abstruse, theoretical physics और relativity का कोई lecture दे रहे हैं, उसको record कर सकते हैं. ये तो बहुत ही elementary है in some way ना. So I mean,
Yes,
ये
sir.
embarrassing है almost record करना और उसको सुनना. I mean, I don't think it's worth that much, to be
So
very
no,
honest.
not because I want to listen to the recording. I'm paying attention in the class, so I'll be done in the class itself. But like majority people are gonna opt for the asynchronous mode for this lecture probably.
Yeah, but you understand it sort of it gives an importance which I think for these lectures is not justified. ये तो basic common sense से हम कर रहे हैं, right?
Yes, sir.
I mean, you understand my point of view, right? I mean, वो थोड़ा
Yes, sir.
वो few funny सा लगता है मुझे. I mean, this is, of course, I have been assigned this course. I have only started, this is only my second time in my life. I have done much more difficult courses. I can understand. उनको record कुछ कर सकते हैं, लेकिन इसको record करना थोड़ा मुझे embarrassing सा लगता है.
Sir, I get it.
You got it, yeah. Everybody gets it, right? Good, anyway. But nonetheless, in one of the things about teaching assignments is many times you're assigned courses. It may have nothing to do with your research or your thing, but you have to do it. So I hope that you understood my lecture, right? I mean वो जो भी हमने कहा वो समझ गए ना आप?
Yes, sir.
I mean you could ऐसा नहीं था कि you could not understand my delivery, right?
So we could understand it
Yeah,
like very well.
yeah, that's good. That's good. That's good. In fact, I'm trying to speak louder because I only listened to that thing that Devpriya had downloaded. I thought the voice was very gentle, but I asked you, you said वो सही था. So I don't know. मुझे तो काफी voice का volume काफी low लगा मुझे ने. So I'm trying to make a conscious effort to speak louder.
So you're pretty
No,
much
sir, it was
audible.
fine. Yeah, yeah.
Yeah, but the recording में तो सुना ही नहीं आ रहा था मुझे ही.
That, sir, usually people listen with headphones or earphones.
Oh,
So
nice. Okay, okay. Yeah, I don't have one. Maybe I should acquire one. One looks a bit like a buffoon, but it's all right.
So is the CO2 balance is of 48 mole?
Gee, I don't know. Let us first go through the steps. So you have correctly. I mean, I don't know the answer. We have to work it out. I mean, the thing is, first you have correctly identified CH4 as the limiting reagent. So now, what you should do is you should find out how much, based on the conversion, how much of it reacted, and then you should apply input minus output equal to consumption, and you can first do that for a methane balance. That would be the logical thing.
18 mole of CH4 would be reacted then.
Why is that?
So because this 0.15 and
20% was the
20,
methane.
yes sir. So 20
You
20
can't
mole
do
of
what you are saying.
CH4 was fed and 0.9 was reacted. So
Right. So that doesn't give you the answer. ऐसे ऐसी गलती कर ही नहीं सकते आप. So that's not the answer you gave me.
I guess, sir, 27 moles of CH4 will be reacted.
Correct. Because
And
0.2
we'll
to
be left
1
with
is
3 moles.
right. So basically 0.2 into 150 or uska 90% has what has reacted, and that is the answer that Ashi just gave me, which is 27 kg moles per hour reacted. So now find out how much is coming in the exit stream. You know how much you fed, you know how much reacted, so you know how much is left over.
Sir, in the exit stream, we'll have 3 moles of CH4 which will be left.
Correct, because
And
input minus output is consumption. So
yes, sir.
basically, so input plus consumption. I mean, input minus consumption. So that would be 30 minus 27. That's many kg moles per hour of CH4 is coming in the exit stream. Now, can we do that for some of the other components?
Yes, sir. For oxygen, we'll have 36
Generally,
moles that will
oxygen
be
we should
left.
always do at the end, but please always keep oxygen at the end. That's a good
Yes,
policy.
sir.
So do other things and oxygen at the end. In this case, it may not matter, but
So for CO2, it is 57 moles, and for water, we'll get 54 moles
okay. So
in the
one,
final.
we have to see in CO2, you can do a CO2 balance to find out how much CO2 was, you know, the 20% mole, right? 20 mole percent. So
Yes, sir.
150 into zero point 0.2 was there. And how much reacted, you know, from stoichiometry, because CH4 was, you just told me 27 reacted.
Yes, sir.
So basically that much CO2, because it's 1:1.
Yes, sir.
So
So we get
27
57
kilomoles per
moles.
hour. So 27 plus 30 is what has to be in the exit stream based on the input minus output equal to consumption. Or rather input plus generation equal to output. You can write it whichever way you want. So yes, 30 plus 27, 57 kg moles per hour of CO2 in the exit stream. Similarly, you said you will do a water balance. So let somebody else tell me. That would be just 27 into 2, isn't it?
54, 50, yes, sir, 54.
54 kilojoules per. Now you can do an oxygen. Alternatively, one can also do a species balance. I mean, atomic balance. I mean, I have only suggested doing a complete species balance, but alternatively, one could have done a carbon balance and a hydrogen balance also. But anyway, let's stick to one approach. Because in a way, you know how many kg moles of carbon is there in methane. You know how many kg moles of carbon is there in CO2. So you can also do a carbon balance. But anyway, both give you the same result. It's up to a matter of your taste whether you want to do the complete species balance like we are doing now, methane and CO2 and water, or alternatively, one can also have done elemental balance. Because you know the 30 moles of carbon was there in methane, 30 moles of carbon was there in per hour went off in CO2, and you know how much was unconsumed. That was what, 3, right? So there is 3 moles there. So basically you can apply now input, but of course one good thing with the elemental balance is that it's always input equal to output, because you are balancing the whole element, right? So, but anyway, the whatever balance we did was for the entire species, CO2, H2O, CH4. But if you can do it, if you want to, if you like, you can also do a elemental balance, and there you always input is equal to output, because you are balancing the total kg moles per hour of carbon, kg moles per hour of hydrogen, what have you. Am I all right? Am I clear? But I don't want to unnecessarily confuse you also. So far I never talked about elemental balance, but alternative approach is also there. So some people say why we should look at every species, let us just look at the element. In energy balance also that is done. They are equivalent. So in a carbon balance, you would have input is output. So 30 went in methane, 30 in CO2, so 60 And then 3 were, however, in the exit stream because methane contained 3 moles of, in 1 mole contained 1 gram atom. So that was 3. So 30 plus 3, input is output. So 30 plus 3 minus 3. 30 plus 30 minus 3 would be the answer. Same answer what you got for CO2 by the CO2 balance. So now you can do a mole balance for oxygen, or you can do atomic balance for O. So do a free oxygen balance for O2, free O2.
For the O2 it was मतलब बता दिया था ना किसी ने शायद 36 mole.
Right, but just give all the intermediate steps. First, what is the free oxygen that is coming in? You know the total flow rate, you know. So just do the intermediate also so that everybody is.
The input
we have
oxygen
to
was
work-
90.
sorry.
Yeah, so that's 150 into 0.6.
Yes, sir. And the consumed was this 54.
27 into 2. Because 1 kg mole reacted, and for every methane reacted, 2 oxygens were reacting for complete combustion. So that's 54. So 90 minus 54 is the flow rate of oxygen. So now write down all the flow rates and see if they total 150. They should know for steady state.
Yes, sir.
You said you had 50 something for oxygen, 50 something for water, 36 right now you calculated for oxygen, and 3 were unreacted, no, of methane. So add them up and show that they are 150 kilomoles per hour. Does it work out? 150 totals? Q totals?
Yes, sir.
Yeah, so that's a good check. So you know, and now you can, generally we ask the composition, so you can find the mole fractions of every product gas. It's okay, right? Because you know everything divided through by 150, 54 by 150, 57, 3 by 150, 3 by 150 for methane, etc. You can find those mole fractions. right? Na? It's
Right,
okay,
sir.
right? It's
Yes,
okay.
sir.
So now one more step which I wanted to do, but I'm not in the mood really. We can add a second reaction of incomplete combustion. I think you will be able to do all of that. I mean, then there is just two reactions. So you will have a CO stream also. It's the to find the limit able to another balance for CO, and you will be able to find the mole fraction. This is the exit stream for two reactions. Not a problem. Let us give something more challenging then. This may, na? Because I think you will be able to do all these simpler ones. Okay, let us just see. Um, you have to of course take it down. I don't have any slide for I haven't chosen. But this one is one could I mean maybe next time we can project slide for it. But take that down and see how you are going to solve it. This will require some thinking. So I'm directly going to the problem we wanted to end our material balance portions with, right? It is recycle is there, 2 units are there. As I said, I can have more than 2 units, but we don't want to do it because of this 1 hour restriction. And the principle is the same. And we also have a chemical reaction. So reactor cum separator, 2 units with recycle working continuously for a reactive system, right? This is the last thing that we wanted to cover. So take it down. Propane is dehydrogenated to form propylene. C3H8 going to C3H6. C3H8 going to C3H6 plus H2, of course. The conversion, overall conversion of propane is 95%. That is the design. That this process is designed for that. The overall conversion is 95% of propane. The reaction products are broken into two streams because naturally we want to recycle the unconverted things, right? So there will be two streams. You can call one the recycle stream, the other the product stream. So the first stream, that is the product stream, contains H2, C3H6, the products, H2, C3H6, and there will also be some unreacted propane, right? So some part of that we are recycling. So this product stream contains C3H6, H2, and take this down carefully, 0.555%. 0.555% of the propane that leaves the reactor. So this is the product stream, composition of product stream. It contains three components naturally, two products and the unconverted thing, and that has 0.555% of the propane leaving the reactor. Now you have a recycle stream which is fed back. So this second stream, which is the recycle stream, it said that it contains the balance of the unreacted propane. That means जो propane product में नहीं लिया, remaining you are recycling. The balance of the unreacted propane plus it contains 5% of the propylene in the product stream. 5% of the C3H6 in the product stream. So if you knew how much of propene was there in the product stream, uska 5% you are in the recycle stream. And this is again recycled to the reactor. So now what are you asked? You are asked to find the composition of the product. And you are asked to find the ratio, recycle ratio, that is the moles you are recycling per mole of fresh feed. R, capital, R upon F. Recycle ratio, moles of recycle upon moles of fresh feed. And you are asked to find the single pass conversion. As I told you, in a continuous step, you can have many passes through the reactor. So by single pass conversion, what is meant is how many moles of the limiting reactant went in, how many moles went out, divided by how many went in. The reactant, that is reactant input to the reactor minus output from the reactor divided by reactor input. That is what is single pass conversion. And you can distinguish that from overall conversion, which refers to what is the reactant input to the whole process. Numerator is the same, but overall conversion means आपने पूरा process को कितना दिया, and single pass means आपने reactant को कितना input दिया. ठीक है? So obviously when you say 95% is the overall conversion, it's based on what was fed to the overall process. Pass, it means what was fed to the reactor, the denominator, I mean. Okay, इस पर आप सोचिए, and we will of course have to continue this next time. So this is like an interesting class of problems. Of course, a more complicated thing would be that I have more than one reaction. But other than that, this is a good one to end our in this week. Deliberations on mass balance. This one will require you to make a proper diagram, identity, and do everything that we have done for this month and synthesize all that in this question. This is a good one.
So what was the amount of fresh feed? 100 mole or 150 mole?
Fresh feed, nothing was said, no? Was something said? You can base it on a basis of 100 moles of fresh feed, no? You can choose a basis which is, as I told you, if certain flow rate or amount is not given, just use always use 100 fresh feed. That's a good basis. The problem doesn't give you that, so base everything on 100. Is the problem clear? By the way, I'm very afraid to ask any one of you. It's a very interesting class because first time I asked the Kejriwal boy and then he never showed up. Dhwani showed up. Do I, do I, is it kind of humor is apparent or? So I'm not going to ask you anybody specifically. So next time से वो आएंगे ही नहीं फिर. Devpriya, do I make sense?
Yes, sir. I
Funny, no?
understand.
So you have to carefully do this. First of all, you will have to label the unknowns carefully because now there is also recycle stream. So you have to first find out recycle stream में क्या क्या है, product stream में क्या क्या है. You have to get that right based on the product problem statement. You cannot afford to miss a stream or put a stream or assume that recycle and product contain all the same streams, etc., etc. So that's the first thing you have to interpret correctly. Otherwise, the entire question will get.
So, just a question.
Yes.
Sir, when we say that the process is designed for the 95% of overall conversion, so it is for the last step, right after the separation.
Correct. It is for the last step.
Okay, so
all the way to the product, all the way to the final product.
So first of all, we decide how much like efficiency we want, and then based on that, we design the separator.
In some way, you can say that, yes. But basically, right now we are not designing anything. But yes, that is something that you will fourth year Sri Krishnan's course on plant design. That's how we do it. Yes. But then that course deals with a lot of mechanical design also, and so on and so forth. But yeah, what you say is right. But here, this overall conversion in a way which relates to the limiting reactant. In this case, it's only C3H8. So it just helps you find out what happens in the product, how much you can afford to have, how much you can afford of unreacted propane you can have. Essentially, that is what this number is telling us in the final stream, product stream.
So composition of products, so like 5 mole of C3H8 would be there.
Correct.
Because 95 mole of would be reacted.
Correct, but there would be a number of other things also in the product.
95, yes, sir, 95 mole of C3H6.
That's right.
And this H2 same 95 mole.
Yeah, because yes. So essentially, you know that composition 95, 95, and 5.
Yes, sir.
But now what you have to worry about is also find this for the recycle stream. That doesn't follow from this. Analysis of product now is correct because you did an overall propane balance. You knew the conversion, so you knew that 5 is there. Then you did an overall propylene balance. You knew that if 95 was reacted, so 95 was produced. So that's how you found out for hydrogen and propylene. But now you have to worry about the recycle streams. That you will not be able to do so just by this kind of. This was fairly simple. You're right, as it turns out. All right, I think let us summarize. So we are now reaching more or less the end of our mass balance portions. Um, Now minors are not too far away, so this it's good that this week we will finish this. We will complete this next time. And if there is anything Thursday, and another thing is, you should definitely form the groups early next week. At least form your group of 6 people, five to six people for your 20%, because now mass balance is done, and then next week we after you form the groups, let us start the energy balance, and then we will complete that by 3 weeks, and then you have to also do the biological part on 1 or 2 Sundays, depending on, before you go off for the semester break. So that completes your course, and then you have enough time to do the 20% project, whatever. Okay, so I think let us draw a proper diagram next time for this problem, and let us you have of course correctly done the product composition. Now similarly do for recycle. Let us do it for the recycle next time, and find the recycle ratio and conversion, because conversion ke liye bhi you will need all the intermediates, interior streams, right? Interior streams. So let us do that, and then let us see if something is left, we can fill in the missing things. More or less, I think we are at the end of and that's all the time we have for. Also, we have to move on to project, forming the team, and then going to energy balance, which is also an equally long chapter. So let me see how much we can do in November, and on this basis we will move on. Okay, thank you very much. I enjoyed it very much.
Thank you, sir.
Thank you very much.